Alright, so this is a video of my pretty much finished power supply here. And I'll show you the inside in a minute. There's two power supplies inside. One is a 24 volt power supply. I think it's about 3 amps or so, something like that. And it's also got a PC power supply, which provides the 12, 5.5, and 3.3 volts. If you know anything about PC power supplies, you know I can get all kinds of other voltages from it, because you can use different negative sources with positive sources and get totally different outcomes. You can get about 7 volts if you use a combination of different wires, but these are pretty much the voltages, the only voltages I use. Really, I don't even use 3.3, but just for testing purposes, just to have there. So they're each controlled by a switch here, and it goes to relays inside, which I'll show you in a second. And it's got these terminals on here that also accept banana plugs, so I can plug those in. And I've got some jumper cables that I use these a pretty good bit. And we've got wires right up here. This is just a project I've been working on. I've been wanting to use my basic stamp with, of all things, a SLC 500 PLC here. You can see each one of these cards has 16 inputs or outputs. So I think I added it up, it was over 140, I think, inputs and outputs. Some of these, like this one for instance, is a TTL input, and what I can do with that is use it with 5 volts, and I can go to anything, any kind of circuitry that I have and I want to build. So I guess that'll pretty much be the test to show you how everything works. Alright, so that turns on the 24 volt power supply. There's no fans on it, which I might have to remedy that, but I don't really know what the temps are inside there. It doesn't appear to get very hot, but I'll probably look at that later. I already have these on. I always start at the power supply too with the 12 volt already on, because I don't have a load yet to put on, just something inside to have some kind of load on the power supply so it doesn't turn on without a load, which can damage the power supply. So if you got any ideas for that, I think I'll probably just get a decent wire round resistor or something. I've heard people will use those, and I've also heard that you should do it on a couple of the different voltages, like I think the 5.5 voltage also is good to have a load on. Alright, so I'll flip it on, and you can hear my Lego ball machine start up because it's now running off the 12 volt rail, which actually is outputting about about 10 volts. It's usually a little bit more than that. Kind of surprised. It's also got 2 fans in there to have some kind of load on it. Let's see, 12 volts also goes to the power, where a 9 volt battery is supposed to go on the basic stamp, but because of this chip here, this takes the input voltage, which can be anywhere from 7 to maybe 15 volts, and it reduces it to 5 volts, so you can use it with I'll go ahead and turn that off. It uses it for the onboard electronics and everything, and you can also run off the power, the 12 volt if you want. The 24 volts is used for the other outputs, that sync and source. It's also got a built-in 24 volt power supply, which I was using before, but this will give me a lot more power to use with it. And that's just some other stuff. But I'll go ahead and show you the inside of the power supply, and that'll, I guess, be it for this video. If you're interested in any of the other crap I've built, I will show you that. So I'll go ahead and switch it off and open it up. Oh, my wires are too short. Okay, so I just got a small terminal strip here for future expandability and just keep things nice and neat and tidy. I've got a fuse on each of the outputs from the power supply, and so that's that. There's the 24-volt power supply there. PC power supply with a CD-ROM on top. Just that's another load thing, but it's only got the 5-volt. I don't know why I did that. These are all the relays here for the front panel, and I'll show you what these LEDs are doing on there. Really, they're not. I don't think they're needed for this circuit. What that does is it discharges the backwards electrical energy that is produced when the relay turns off. It actually produces a difference in potential in the opposite direction, and so that can absorb it so it doesn't feed back into your electronics or your controller. So you can see they already have lights on that actually show if they're on or not. So you can see that's the 5.5 and the 3.3. And watch when I turn them off, you'll see the LED do a short burst, and that's from the discharge. So that's pretty much it. So thanks for watching. Send me your ideas and make your own videos. Peace.